Following is a sequence of circled X's and circled dots. How many circled X's are needed for the 170, they should have said the 173rd term, but they said 173rd term. So a little bad English there, but that's all right. It's a math class. So what are they talking about? Term number. Let me write that out for you to make it more clear. This is the first term. This is the second term. See how they're separated from each other by commas? That the terms are. One term is separated from the next term by commas. That's the third term. There's the fourth term. And they want me to go dot, dot, dot. Oops. What is the 173rd term? That's what they're want me to figure out. Well, they want me specifically to tell them how many, circled X's. So there's one circle X in the first term, 1, 2, 3 circled X's in the second term, 1, 2, 3, 4, 5 circled X's in the third term, 1, 2, 3, 4, 5, 6, 7 circled X's in the fourth term, etc. So, question is, how many circled X's in the 173rd term? Well, we can see the pattern, can't we? We can see it's just odd numbers, right? 1, 3, 5, 7, etc. It's just adding 2 every time, right? But how can we use that pattern to get all the way out to the 173rd term? I mean, we don't want to, I mean, we can do them one at a time, but that would be terrible, right? We don't want to just like add 2, it's 9, 11, 13, 15, 17, go all the way out to the 173rd term. That would be awful. Instead, we want to use a pattern that will allow us to jump all the way out there. That's the power of math and science. That's what we want to be able to do. That's the power of math and science, is patterns. We are human beings. We can observe patterns. I know people talk about animal intelligence, and animals have a little intelligence, but it's nothing. It's just silly, really, when people try to act like they're almost like us. That's just ridiculous, because beavers, for example, can build things, little dams and stuff, but they're building the same dams they were 2,000 years ago. And now we're going into space, right? So the fact is, we have something they don't have, something so much more profound called logic. That's what it is. We can deal with patterns. This is logical thinking right here. And this allows us to jump to the 173rd term without doing all the terms in between. And it also allows us to go to the moon and maybe to Mars, right? So it's logic, and it's a very powerful, uniquely human ability. I mean, real logic. I know animals can do very, very simple logic, but it's crazy different what we can do. Abstract logic. So how do we do it? Let's practice it. It's a very valuable skill. It's what drives all of math and science, is dealing well with patterns. How do we do it? Remember what we did on the other ones. We need to write out where these numbers are coming from. Where did the 3 come from? 1 plus 2. What am I going to write for and this is just 1. You just start with 1 here. And then 1 plus 2, right? You have to see a pattern, you have to look inside the number. We can't just look at 1, 3, 5, 7, but we have to write where they came from, because that's the engine. It's making the car go down the road. So like with a car, if you want to see the engine, you got to pop the hood and look inside. That's what's making the car move. What's making these numbers 1, 3, 5, 7 pop out is the engine inside. So what am I going to write down here for 5? I got to write the engine that made the 5.
One plus two plus two.
Good, good, exactly. 1 plus 2 plus 2, right? And then the 7, 1 plus 2 plus 2 again. Great, exactly. That's where they came from. That's the engine. That's the insides of those numbers. We just kept adding another 2 at the back, didn't we? We started with 1, added a 2, added another 2 at the back, added another 2 at the back, etc. Okay, good. Is that helpful now? Now, so that's one thing you have to, in order to observe the pattern, you have to first see the pattern. You have to write it out. Now, the second thing you have to do is be focused and clear on the connection you're trying to make. What connection am I trying to make? I'm trying to connect this number, 173, with how many circled X's, right? So if I want to connect this with this, then I got to look back and say, well, how does this connect with that? And this connect with that, and this connect with that, and this connect with that. That's the pattern I'm looking for. Does everybody see that? See how I came up with that? I just simply went to the end and said, well, they want to know 173rd term. So I'm trying to connect the term number with how many is down here. So I better look back and look at that same thing. Term number to what's down here. Term number to what's down here. Okay, so how do we do that? Do you see it? So for 7, how many 2's do we have?
Three.
Right. So for the 4th term, we have 3 2's. Right? We're trying to connect the term number with what comes down here. This one has 2 2's. So for the 3rd term, we have 2 2's. So it's a little different pattern than we saw before. Y'all seeing that? Can we jump to the 173rd term now? For the 173rd term, it's got to be a 1 plus 2 times something, because all the rest are, right? 1 plus 2 times what?
172.
Beautiful. It's got to be. Does everybody see that? See how that matches? See how this number is always one lower than the term number? Do you see the pattern there? Whatever the term number is, you have 1 less than that. Multiplied by 2, add 1. Right? Whatever the term number, you have 1 less than that. Multiplied by 2, add 1. Right? And whatever the term number, 173, 1 less than that, multiplied by 2, add 1. Yeah, that's the pattern. And then just hit the buttons on your calculator. Right? Just go, okay, 1 plus, what is this? 344. So it'd be 345. Got it. The 173rd term must have 345 of those little circled X's. We got it by the pattern.